All right. Looks like we've got people settling in. So, thanks for joining, everybody. This is a presentation on Autodesk Fusion 360 called "What is Next Generation CAD?" My name's Jake Bosman. I'm actually in Minneapolis, St. Paul. Manage the territory here with Autodesk Corporate, and I am accompanied by Dan Luby, who is my counterpart, a technical specialist. Dan is originally from Minnesota as well, but he's currently in Chicago. I believe he's still a Vikings fan, though, so don't hold it against him. I think that I'm going to go ahead and kick things off. I have a couple of things to show at the beginning and just kind of give you some background, set the stage for what Fusion 360 is, why it's a little bit different, actually a lot different than what you may be used to in terms of design tools or CAM tools. And then we're going to spend the majority of the time just allowing for a presentation and demonstration of the product. So I'm going to go ahead and move forward. Here's the agenda for today. Let's see if my screen will work. The agenda for today is I'm going to give you some background. We'll do a technical demonstration, talk a little bit about something that's going on tomorrow, and tomorrow only, and then we'll have time for questions and answers at the end. Please feel free to use your chat window to ask those questions throughout, and we'll make sure to answer them at the end. So Fusion 360 is a very different form of design and product development. It's different from the traditional tools in a number of ways. Integrated, connected, accessible. Current CAD and CAM platforms are often fragmented, usually expensive, dollars per year in maintenance and upfront costs, and disconnected, and oftentimes just limiting in terms of how you can transmit and share data across those different platforms. So what we're doing is we're actually bringing together technologies that had previously been separate. We started by having mechanical design and industrial design tools together in one cloud application, and then we built data management into that environment, and we brought together design tools with visualization, simulation, and fabrication, so CAM and 3D printing tools, to address kind of the future of making things. And we also built an ecosystem so that people could share and collaborate their work with increasingly distributed design teams across, let's say, internationally, or even with your customers or partners or vendors. We think that that's the right vision for solving the complexities in today's design team. So I'm going to go into each of these very quickly. One, it's an integrated product development platform. So it's one platform to really kind of take the entire design process through ideation to concept, engineering, and production. So we have form, design modeling tools, sculpting, finishing, rapid iteration, and rendering. When you talk about function and engineering, FEA analysis, motion, fit, function, animation. And then also built into the tool is the fabrication side, which is our HSM kernel. With the acquisition of HSMWorks, we've actually ported that technology into Fusion, where you can do 3D printing, CNC, 2D drawings, prototyping. And the beauty of everything that is happening with this is you can actually collaborate with stakeholders internally and externally throughout this process if you would like, and you grant them the privileges to do so. So secondly, we're connecting teams. So you can access this system from anywhere, and you can access with anyone. You can collaborate with design, you can collaborate with sales, your customers, engineers, and what you can collaborate on are a lot of different things. So models, different drawings, let's say schematics or videos, even renderings and specifications. And so what we want to do is we want to enable people to interact with each other in a more efficient way. And finally, what's actually very different about Fusion is it's not just licensed to your computer. It's licensed to you. So you have a username and login, and you can install Fusion on any device, whether it's Mac, PC, tablets, iPhones, and you can use it online and offline. One of the beauties of this product is there is a short learning curve and an intuitive interface for fast learning. And we do have a great team, a street team, that will help our customers to learn this product in a very fast and efficient way. Here's just a quick example of a company that used Fusion that I think is very interesting. They went from 8 product development tools to 1. Now, not everyone uses this exact same use case. Some people use Fusion for CAM. Some people use Fusion for design. But this particular company was able to replace 8 different software programs, lower the cost of the ownership of those software tools, and then improve their product development process in the way that they could share designs and import designs with over 50 file types while working with their customers. So that is my quick rundown of Fusion 360, and with that being said, I'm going to go ahead and pass it over to Dan Luby for a demonstration.
Sounds good. I appreciate that, Jake. And I'm going to take over, and then if I could just get a confirmation that you can see my screen okay.
I can see your screen.
Perfect. All right, well, welcome everyone. Like Jake mentioned, my name is Dan Luby. I am one of the cloud manufacturing technical specialists here at Autodesk, and I really support the product innovation platform that is really all of our Fusion products. At the center of that platform is Fusion 360, and that's what we're going to be looking at today. And that's what we're looking on the screen. This is Fusion 360. In terms of CAD, I have quite a bit of experience in CAD. I've used tools, SolidWorks, Creo, Pro Engineer, used a little bit of AutoCAD, used Inventor in the past. I come from a pretty diverse CAD background, and I have to tell you, I actually came from the SolidWorks partner channel to join Autodesk because of what they were doing with the Fusion platform. I think it's phenomenal. I love how the system works. I love all of its capabilities, and like Jake mentioned, it really ties different personas within an organization together to kind of streamline the development process. And when we talk about Fusion as a whole, Fusion 360, this is a hybrid cloud product. And what I mean by that is some things are done locally, other services are done in the cloud. And we'll take a look at some of those things as we go through this product demonstration. But one of the best parts about how this system was developed is the way that we output changes, right? So if you think of traditional CAD systems like SolidWorks, even Inventor and Creo, every year they have a major release. We're going from 2015 to 2016, then from 2016 to 2017, and in between there's like all these little service packs that we have to download and install on a pretty regular basis. Very time consuming in large organizations. Fusion, everyone is always on the same version. When we output new features and functionality, it's automatic. So when you wake up in the morning and you fire up Fusion and a major release has been, or excuse me, a major update has been released, which we'll be having one tomorrow that I'm super excited to talk about. I'm going to wake up tomorrow. I'm going to get a banner at the top of Fusion that says, hey, I'm downloading and installing an update. Our goal from a development standpoint is to always have that update occur in under 2 minutes. I'm just going to close down Fusion, reopen, and boom, I have new features, new functionality, bug fixes. I mean, everything is automatic. I don't have to like download anything specific or go to some URL to find the files. And I love that personally about this. There's also no interoperability issues. So when you're working with someone with Fusion, you can just be sharing data back and forth without the hassle of, well, do you have a newer version than I do? And and that can lead to some communication issues downstream. So we're looking at the interface right now. Obviously, I have my CAD model on the screen. This is the Autodesk Ember printer. We'll talk about that for a brief second. But I want to talk a little bit about the layout of the UI. Like a traditional CAD system, depending on the workspace I'm in, I have a various set of features and tools to use. And what I mean by workspace, we break down Fusion into what we call workspaces. At the very top, we have this modeling workspace. This is where you're going to do all of your upfront conceptual design, your sculpting in the freeform workspace, your surfacing, your parametric modeling, your direct editing. This is where we're really generating geometry and creating our 3D models. We have another workspace somewhat tied to the model workspace. This is what we call the patch workspace. This allows us to work with traditional surface tools. It also has a lot of features for when we import data, if there's any sort of translation issue. I'm sure a lot of you who import data have seen this before. You bring in a step file, or you bring a file from another CAD system and you have maybe open surfaces. We have a lot of really good patching tools and direct editing tools for working with imported geometry. And then we move into tools like render, and this could be a totally different persona within the organization. It could be a marketing person. They can come in and start to access data within the system, going into the render workspace to start utilizing things like cloud render. right, where they're able to send up renderings to the cloud to be processed so it's not using local resources. Then we move into an animation workspace. A lot of folks think, we don't really use animation. We don't need to show how our product works. And I completely understand not everyone needs to show that information, but what about like technical documentation, like disassembly or assembly procedures? These are the types of things we can record in animation workspace, and they're always tied to that single source of truth. So if I ever make a design change in the model workspace, my animations are automatically updated. And then we move into things like simulation, where we're going to go virtually test our model and product to make sure that it doesn't break in the real world. And while most people think of FEA analysis as a very cumbersome and hard to learn tool, we've made it very easy inside of the Fusion 360 tool. I also like to look at simulation as adding two benefits, right? Number one, obviously, is making sure that our product doesn't break. And hurt someone, or just break and we have to deal with warranty issues. But number two, if we over-design things, FEA can actually help us understand where we can use less material to reduce cost or even lightweight components that we're designing in the model space. And then finally, downstream, into the manufacturing space, we have a CAM environment. So you can take the stuff that you've modeled, that you've rendered, that you've created animation for, and you've tested, and you can then go and generate your tool paths to go start cutting and actually fabricating the things that you've created. So we tried it, we wanted to put together this product development platform that encompassed everything from start to finish. And I think we've done a really good job at that. And so we'll try to touch on each of these workspaces at least a little bit so you can get a kind of high-level overview understanding of how these all work together. Excuse me. So before we get into the actual modeling aspect, I want to talk about two things that a lot of people have to deal with today. Actually, we all do. And I want to talk a little bit about how Fusion's different. And those two things are data management and collaboration. So what you're seeing on the left-hand side over here is a project folder that is in the cloud that resides and holds all of my data that I've created inside of Fusion. It actually also holds data that's not Fusion related. We can actually upload data that's Word documents, Excel, Office documents, PDFs, image files. We can really upload any type of data into this data management repository that you can manage on Windows Explorer. So you can bring everything related to this project into one central space, and once you have all of that data in this space, you can invite people to collaborate with you on that data. So as an example here, if I want to invite Jake into this folder, all I have to do is type in his name, and I just hit invite. And now you'll see he'll get an email notification when he accepts. His name pops up into my list down here, and now he has access to all the data in this project folder, and we can start to collaborate with one another on the data that's in this folder. In terms of data management, if I go click on an individual file, so this Ember printer that I have open currently, if I click the information button, I get some very important details about this file, including previous versions of this file. So in terms of data management, it's something we all have to deal with in the CAD environment, right? We start to make relationships between files. We've tried to, from the beginning and conception of this platform a little over 7 years ago, have really focused on making data management as transparent to the end user as possible, because no one wants to actually manage data. It's not a fun activity, and it's definitely not a value-added activity. And so what happens in here is as we design and we work with our product, we actually create versions. So you can imagine this is the same document, but with just a design progression as this thing has moved through development. And at any given time, if I need to go back to a previous version and use that as the latest, I just come over here and I click promote. And what happens is it'll take the current version, which is version 4, keep that, and it'll make a version 5, which is exactly what it was at version 2. So it actually allows me to always keep what I've done in the past. Another big benefit of this is I can come back at any time and I can open up a previous version of a file side by side the latest to see what those changes look like in real time. And that's always super powerful. We also have direct links to drawings and any child documents that we need to review. Now, if I need additional information, I can actually open details on the web, related to this file. And to kind of demonstrate how we can access data within this project folder on the web, I'm going to actually log in and I'm going to show you my iPad. One sec. Let me just pull this bad boy up on the screen. I'm going to log in and I'm going to go to this project folder as though I'm a user who maybe doesn't have Fusion 360. Oops, I'm going to kind of back out here. I'm showing too much already. And what happens as a user, someone like maybe Jake, who's a sales rep, or maybe he's a project manager and doesn't actually do any design, I can invite folks into my project folder who do not even have a Fusion 360 subscription. And they still have the benefit of being able to access this data in real time within this project. The only thing they wouldn't be able to do is open the file up in Fusion and make any sort of edits. But anyone in your organization that needs to see data, needs to consume stuff that's created within Fusion, they can do so from any device. And I'm just so happen to be doing this on my iPad. So I'm going to go into this project folder and I'm going to open up this Ember printer file. And again, I could be reviewing this data in my browser, on my PC, on my Mac. I could even be on my iPhone if I want to. But what happens is the user clicks on the file, and what happens is it loads a viewer, right, in the browser. It doesn't require any install, which is super powerful, and they're able to come in and start to understand, how this design has been put together, where we're at within the project. They even have the ability to review comments that have been made about this file. So this is where we talk a little more about the collaborative nature of Fusion and this entire platform. We have a dynamic scrolling, almost like social media-ish way to communicate with one another about changes in direction of a product during the development. So you'll see here I have a bunch of comments that have been made by this alias of James Doe. That's technically who I'm signed into as on my iPad, so we'll just pretend I'm more or less a project manager. But I can now come in as James Doe, and I can kind of like orient this model how I see fit. I can measure, I can quickly mark up. So if I want to come in here and specify that, hey, we need to work and design something that holds this pivot head in place, I can come in here and just type in, hey, Dan, can you design an arm cap? And what happens is he's now posted this to that dynamic commenting feed, and I get an email notification with a link to this file along with his markup, so I can see what it is that he said. And if you notice down here in the bottom right-hand corner of the Fusion application, I get a little pop-up saying, hey, James Doe commented on this file that you have open, right? And it shows me a little bit of what he has written in terms of his markup. Another good thing I like to share, actually, I should open this back up, is the ability to kind of share out this file, right? So let me go in here. Actually, you know what? We'll do this in the browser on the computer. I'm going to close this down. Another big way of sharing information with one another is because we are cloud-based, I can come to any document I have in any of my project folders, and I can share a public link. And although it sounds like I'm just putting it out for the entire public, it's really only to specific people who receive the link. What they can do, if I click Share Public Link, all I need to do is copy this URL. I can come in now to an incognito browser. Notice here I'm allowing the item to be downloaded. I'm going to pull this over onto the screen, and I'm going to paste that URL. This could be a workflow where you need to share data with someone externally. It could be a vendor, it could be a customer, it could even be just someone else within the organization that you haven't invited into the project folder. And what they're going to see within the browser viewer is not only this dynamic CAD data, they're going to be able to explode the model, they're going to be able to see properties, but more importantly, I've given them the ability to download, and now that user can go choose what download format they need. So if I'm sharing information with a customer, and maybe I'm sharing that same link with two different customers. Customer A needs a step file, customer B needs a DXF. They can come in and they can choose the format they need, and what happens is the translation happens on the cloud. So there's no need anymore to translate locally using your current system, attach it to an email, and then send that email off. Right? The other big benefit here is when I share out this link, it's actually always bringing the user to the latest version. So as you continue to make changes in the Fusion system, your suppliers, they can always use that link to go get the latest version. I've heard a lot of horror stories of where folks will attach a step file to an email, send it off to someone, then they make internal changes, then they try to send that off, and then the customer gets confused, or their vendor says, I don't know which version's the newest. It becomes a very big communication roadblock in that product development process. So we're trying to rethink the way that we communicate, the way that we manage documents, and I love the way that we've put this together. So I'll kind of close this out. I'm going to close out my data panel so I get a little more real estate in here. And again, all of those comments that were added to this document are actually accessible directly within the Fusion application as well. So the Fusion user can be having a dialogue back and forth with someone who's maybe reviewing on an iPad or in a different country. So the question we've had today is, hey, we need to go in and we need to design an arm cap that encompasses this spherical ball to kind of hold our printer head in place. And so what I want to do is kind of open up that document, and we're going to go through some of the modeling techniques that Fusion 360 has to offer, and then we'll run through all those various workspaces to see all the different types of content we can produce in this system. But before I do that, I want to just take a quick second to talk about the Ember printer. This is the Autodesk Ember printer. We developed this and made it entirely open source. Our whole goal behind that is to help push additive manufacturing or 3D printing technology further into the future. So, when I came to Autodesk, this is really what I saw in Autodesk, is really looking to the future, trying to start incorporating some of these newest technologies we've been hearing of into the system and making it easier for organizations and customers to use and harness that technology for their benefit. So I'm going to come into this file. And what we're going to do is we're going to start to design an arm cap. So we're going to develop a single component within this assembly. This assembly is called a build arm assembly. And you'll notice right now my assembly is the active component. If you think of traditional CAD systems, if I want to create a component in the context of an assembly, how would you typically do that? Well, you'd probably have to go up to your ribbon, start a new virtual component, or some sort of like add component to assembly. Then it's going to ask if you want it to be virtual or if you want it to be its own existing referenced file. That's how those systems are really meant to be used from a bottom-up approach. I'm going to make a single part in a single file, then I'm going to make another part in its own file, and I'm going to bring those two parts together in an assembly. That's bottom-up design. Here in Fusion, we can do that, but we're actually more conducive to top-down design, where I'm in the context of my assembly, and I just have thoughts in my head of what I want to do. I'm just going to do it. And so hopefully you can kind of start to see that as we go through. I'm going to start at my assembly by just creating a sketch on an existing component. Right? So I'm going to be automatically projecting those edges from where I started my sketch. And what I'm going to do is I'm going to close this profile so that I can create an extruded feature that will become a new body within my assembly. So here, Fusion doesn't matter if lines end at the appropriate segment. We can bypass them. It still understands that this is a closed profile. And what I can do now is use this neat tool called Press Pull. It's really like 4 or 5 different features in one, and we'll demonstrate that. But I'm going to go ahead and grab this Press Pull. And what I'm going to do is I'm just going to highlight these sketch profiles that I created, and I'm going to pull this out to create my extrude. Now before I do that, I want you to notice one thing. Right now my build arm assembly is my active component. If I pull this out, it automatically wants to cut that ball component, and so what it's going to do is it's going to automatically activate the appropriate component for the feature it thinks I want to create. So think about that. I am going to create an extrude cut, and it's going to put that feature into the appropriate component for me. I've had so many circumstances in tools like SOLIDWORKS and Inventor where I end up making this feature at the assembly level only to realize it's an assembly level feature and I didn't actually put the feature into the part. This system is more intuitive than that. It understands, hey, we want you to design freely and more, quicker. So it understands and puts the appropriate features where I want them to be. Now in this circumstance, I don't want to cut. I actually want to create a new body, and I want that body to be 25 millimeters, so I'll say OK. And what happens is it reactivates that top level, and it puts this body at the top level of my assembly. Now, I've created a body at the assembly level, and you'll notice some of that graphical representation that those two surfaces from those two components now are overlapping. So what I'm going to do is I'm going to use a Boolean operation, a tool called combine, and I'm going to use that ball to etch away material from this component that I just created. So I'm going to use the tool, an operation of cut, to use that ball to cut away material where the two overlap, and I even get a little bit of a preview of what that cut will look like, and I'll say okay, and what I'm left with now, if I look at my bodies folder, is body number 1 and body number 2, which is the inside of that sphere. I don't need this body anymore, so I'm just going to right click and say remove, and that gets recorded in my parametric timeline. So just like every other parametric system, if I want, I can roll this back and boom, I have my body back again. So we're keeping track of your design history as you go through this document. Now another thing, when I do a Boolean operation, technically this ball component, its surface is theoretically sitting on top of the surface right inside of this spherical cut. So I'm going to use this same press pull command, only this time when I choose a 3D face, it chooses to create an offset feature for me. And it's almost like direct editing capabilities where I can expand and contract this 3D surface. I'm going to add a little bit of a tolerance. I'm going to do a 1/4 millimeter to open up that face. And then I'm going to use the same press pull command, and across two different components in my assembly, I'm going to apply a fillet feature of 2.5 millimeters. So that right there, be able to apply a feature across multiple components, something you wouldn't be able to do very quickly in another system. You'd have to activate component A, apply your fillet, activate component B, apply your fillet. Right? Our whole goal here is to speed up the design process. And you'll notice down here, I hold my cursor over this fillet feature, it understands that it's across multiple components. So if I were to ever take this body, when I create a component from this, if I want to split this off into its own file, it knows to grab that fillet feature and bring it into the feature tree of the newly saved copy of that arm cap. So I'm coming along. I'm going to rename my body arm cap because that's what the component name will end up being eventually. But let's continue designing. And one of the things I notice here, I have this convex and concave surface down here, and it kind of created these 3 weird surfaces off of that projection when I created my top extrusion. Fusion has great patching capability. I can essentially highlight faces, I can highlight features, and I can just hit the delete key and it understands and patches those surfaces appropriately. Something like this hole, if I don't like it, I hit delete, right? And I'm going to go back and undo that because I do want that hole. But you understand we can patch things very easily. The system has very good direct editing capabilities, and you'll notice that as you start to import existing CAD data in maybe STEP or SOLIDWORKS format, you're going to be able to do a lot more to that model than you ever thought was possible with some of the direct editing capabilities in here. So the next thing, I'm going to highlight this face, and I'm just going to come into my sketch tools, and I'm going to grab my center diameter circle. It automatically starts a sketch for me. I'm going to come out and just make a generic sketch shape. When you get good, you'll notice when I right click I can come down to sketch tools and grab sketch dimension. But if I get really good in Fusion, I can just start drawing lines to the tools that I need. So I'll come in here and I'll give this a value of 12, and then again, same press pull tool. I'm going to highlight this profile and just etch away 10 millimeters of material, and then again I'm just going to kind of open this up with a couple of fillets. 2.5 millimeters. And again, the system is recording everything I'm doing down here in the timeline. So to kind of speed up this process, I do already have a sketch created over here for some bolt holes on this opposing side. I'm just going to grab these real quick and do the same thing and just bring these back. We'll bring those back 8 millimeters, and I'll say okay. And so at this point, I've come a long way in a very short period of time with some of the tools that I have inside of Fusion. But this is kind of the most forward-facing component in our Ember printer, and it's going to be the component that's moving up and down, probably attracting a lot of visual attention as the machine is working and printing. And so maybe I've been asked to produce a more aesthetically pleasing component that encompasses this ball pivot. So I'm going to use some freeform surface modeling tools to etch away and make this front surface a little nicer looking. And now, before I get into the freeform stuff, I do want to talk a little bit about surfacing for those of you who do that today in the traditional systems. Surface modeling in traditional systems works something like, I'm going to create a sketch, right? I'm going to create a profile, and then I'm going to like sweep or loft this to another sketch profile, and then I'm going to manage that complex surface with guidelines or guide rails, right? That's like traditional surface modeling. Then I'm going to like do some patching and stuff like that as I bring surfaces together. We have all of those same surfacing capabilities inside of Fusion, but what I like to showcase is our T-spline technology. So I'm going to come up here, and I'm going to click Create Form. You can almost imagine this would be Create Surface. And when I click this, it's going to make everything else in my model transparent. And I'm going to use a utility to convert the front face of this, this component right now into a single flat rectangular surface. And that surface is divided into 4 by 4. Right? So I have 16 faces in this single surface. And the reason we divide them, subdivisional modeling, is so that I can start to manipulate this surface with push-pull capability. So I'm going to come and say OK, and I'm going to right-click and say Edit Form, and you'll notice I can highlight faces, edges, or vertices. And when I do, I get a triad. This triad allows me to manipulate and translate in the XYZ. I can scale in XYZ. I can scale in 2D and 3D, and I can rotate. Right? So you actually are able to move whatever you've selected in just about any direction. So as an example, if I pull this out, you'll notice I've just pulled out this surface at a specific point, and it always wants to maintain G2 continuity. Now, there are going to be certain circumstances where if you don't need G2, you can use a crease command to kind of put a hard edge in this model. So as I go through, let's highlight this top edge, and holding control, I'll grab the bottom edge here. I'm going to pull this surface back on the top and the bottom 4 millimeters. Then I'm going to take this opposing side here, and I want to wrap this kind of back towards this, this counter bore. I'm going to come back 7 millimeters with this edge. Then I'm going to swing around to the opposing side. I'm going to highlight this edge, and I'm going to bring it back just slightly. Right, so maybe we'll come back just 2 millimeters. And when I say OK and I finish my form or surface, I'm left with a surface body at my assembly level. And you'll see it's found in my bodies folder. I have my arm cap solid body and body number 8, which is going to be my cutting tool. So at this point, I'm going to hit S, and I'm going to search for my split body command. And I'm going to split this arm cap with the surface that I just created. And when I say OK, what I'm left with now is a split arm cap, and I can take these two bodies now. I don't need them anymore. It was a part of my modeling technique, and I'm just going to remove them. And what I'm left with now is this nice contoured front face that's a little more visually appealing to me and the folks that are, you know, seeing this model or product in action. So I love that part. You know, I used to use traditional surfacing methods, and there, by all means, you could have done exactly what I just did here with traditional surfacing, but I don't think you could have done it as fast. There's also so many additional capabilities within the freeform space. I only have a short period of time today, but I definitely recommend you go explore that on fusion360.com, because we have lots of videos on the freeform and T-spline technology. Okay, so at this point, I'm pretty happy with what I have here. So I'm going to take my arm cap now that I've designed in the context of my assembly, and I'm just going to right-click and say, hey, this is a component now. As soon as I do that, it goes into my assembly tree, and it becomes its own component. And this allows for two things. Number one, this part now shows up on my BOM in my drawings workspace, or my parts list, whatever you may call it. And it also allows me to apply motion to my model. So as soon as my body becomes a component, I can now pull this thing apart, and I can assemble this with motion. Now, in a traditional system, that's exactly what I would have to do. I would have to pull this thing apart, and then I would have to say, hey, this face and this face, put a mate there. Bring those two faces together. And then after I do that, I would have to say, hey, take the axis from this hole and the axis from this hole, and let's align these two in a concentric way. right? And then I'd have to figure out some other way to kind of map the other side as well to kind of basically eliminate all the degrees of freedom because these two things are going to be bolted together. Now, like I mentioned at the beginning, we're very conducive to top-down design. I modeled this thing exactly where I want this part to be. So I'm going to revert it back to its original designed position. It's still technically free to move, but I'm going to use something called as-built joint. And this is our assembly methodology. Instead of removing degrees of freedom with mates and constraints, I just highlight this component, and I specify the motion that will happen between the two. So it's 2 clicks, technically 3 if you're choosing a different type of motion. Another example of that is if I come back here to my tree, let's turn this ball component back on. I'm going to use the same as-built joint, and I'm going to say this sphere and this component, they're not going to be rigid because this ball can revolve. So I'm going to choose revolute, and then all I need to do is specify the revolution axis. And I click that, it gives me an animation of the actual movement of the ball within that arm base. And it's going to be hard to see across the webinar, but you'll have to trust me, it's rotating. I'll say okay. And that's really how, when we're modeling in this top-down approach, it's so much faster. I can see in the context of what it's going to be interacting with in the real world when these parts are actually put together. So it allows me to make these minor changes on the fly without having to go back and forth between an assembly file and a part file. Now you're probably wondering, well, what if I do want something as an external file, right? What if I want to bring in something else? Let's talk about hardware, right? I want to bring in hardware to this hole. Let's pretend that this thing, we may not have specified a hole size yet, but let's just bring in some hardware from McMaster Car. We have a lot of really, really good relationships on the Fusion platform, and one of my favorites is McMaster Car. So we have an embedded McMaster Car website directly within the Fusion application, and I can now come in here and I can come and search for the hardware I need for my assembly. So I'm going to come down here and we'll just grab some generic socket head. And I know the size I'm going to eventually get, so I'm just going to go to this M5. And I'm going to come to the CAD file, and I'm going to come down here, and I'm going to choose step, and I'm going to hit save. And what this just did is it grabbed that hardware 3D data from McMaster Car's website, and it inserted it directly into my assembly. And so if you imagine me bringing in data into this this assembly, this is how we assemble things, right? Instead of using the as-built joint for things that were designed in the context of where they'll be, I'm going to use a regular joint. So I'm going to zoom in, I'm going to grab a reference circular edge from my hardware, and I'm going to come here now and I'm going to zoom in and say on this face here, right here on this point, I'm going to snap that into place and flip that bad boy around. Right now it's on the type of Revolute. I could change it to rigid if I wanted to. But that's how we'd really bring in data from an external source. If it's legacy data that you may already have, or if it's information from systems like McMaster Car. It even inserts the appropriate part number for McMaster into my assembly tree for my bill of material. Now, I put a thread in here, or excuse me, I brought a piece of hardware in here. What if I want to apply a thread to this model? Right, I want to make sure it's the appropriate size. I'm going to come up to my Create Tools and I'm going to grab my thread. And I'm just going to choose the hole that I want to apply my thread to. I'll come and specify my designation. I'll leave this on ISO. And I'm going to come down and go to the size of the fastener I got. So I got an M5. And check this out. If I ever want to prototype this arm cap that I've just designed, and I want there to be a thread in the actual 3D print, how would you typically do that? Right? In Fusion, I'm just going to model that. And what it does is it takes the thread designation and makes an accurate 3D thread in my part for 3D printing purposes. And so you're probably asking, cool, I mean, now we can just export this out as an STL, right? Yeah, absolutely. I can come down to this part and I can say save as STL. I can manage this additional STL file. I can go put that on a network drive, go to my printer's hardware and software, load up that STL, and be on my way. But we actually do it a better way inside of Fusion. I'm going to come up to my Make button. You'll notice we have some other relationships with some prototyping businesses out there, but the best one is this 3D print. I click 3D print. What do I want to 3D print? I want to 3D print this arm cap. So I'm going to highlight the component within the Fusion assembly. It's going to break that apart into its refinement, or excuse me, its mesh, so I can visualize what this STL file will look like. If I need to change the refinement, I have that ability. We even have some advanced options if you need to make small edits. And then what I can do is I can output this directly to my printer's software. So here I'm running Kira. I actually am in need of updating my Kira software, so I'm not necessarily going to send it today. But when I say OK, it fires up Kira and puts this model directly into the print bed of my Kira software. I run a little printer bot at my desk. And I mean, I just eliminated the process of having to create additional data in the form of STL. I've also eliminated the hassle of like having to go save that to some location, probably give it some antiquated file name in some special folder on the network, then go over to my, it's like I'm keeping everything associated to the single source of truth inside of Fusion 360. So I love that part in terms of prototyping. Let's turn this bad boy back on. And, I'm kind of done. I like where I'm at here. I'm going to come down to this here, and I'm going to say, hey, Jake, I'll just say I've finished the arm cap. What's next? Right? And I can even grab a quick screenshot of what's on the center of my screen, and I hit post, and now Jake gets a notification that I've commented because he's been invited to this project folder, and I can wait for his response. Now, while I wait for his response, let's take a look at another environment called render. All I do is I click on the workspace. It gives me a new ribbon of tools related to rendering, and I can come in here and I can start to understand, okay, let's produce some marketing material for this new printer head subassembly. Right, so what I'm going to do is I'm going to start with appearances. I'll open up my appearance library, and we're really just a drag and drop material library. So I come down and find the material I want. I just drag and drop it onto the model. I like the look of that right now. That's good. I'll close this out. And let's maybe add a decal. So I'm going to grab decal, and I'm going to say front. Oh, looks like Jake commented back on this. Can you run some FEA analysis on that? Absolutely, Jake. I'm going to apply a decal to a face. And this front face is very contoured. I'm just going to select it anyways, and I'm going to hit select image and just grab this Autodesk icon. And what you'll find is we have very easy to use decal installation. Right, I can kind of move this around. The system does a phenomenal job at maintaining the image file's aspect ratio, even across very complex and contoured faces. When I'm done there, I can say OK, and I'm liking how this is looking. So I'm going to orient this. I have the ability to come in and update the scene to make a background, change my lighting, change some values for diffusion and occlusion and stuff like that. I even have the ability to control textures. So a good example that you'll see in this tooltip is wood grain, right? That can be a very hard texture to just slap onto something and have it actually look real. Sometimes it needs to be tweaked, right? We give you easy controls for scaling, orienting this text image within an appearance to make it look as real as possible. And actually, if you're using wood, we have an excellent 3D wood texture map library for specifically woods for those of you who are maybe in the furniture business. But besides rendering, it's very easy to use. You'll notice my rendering gallery at the bottom. I have 4 images over here that are kind of associated to old versions of my file. You'll also notice over here, one of my favorite things, this render on save. Any image that I've done in the past, if I want that to always be up to date when a new version of my file is created, basically during any design change occurs and a new version has been created, any image that's on the left of this little wall right here will automatically be re-rendered in the cloud. So think about that. You have marketing folks coming to you all the time. Hey, can you give me this image? Can you give me this image? Oh, you made a design change. Can you give me that same image? You'll always have updated renders associated to new versions after design changes. It's awesome. The other benefit of a render environment here is cloud rendering. So as soon as I hit render here, it's going to save my document because I applied an appearance. And what you're going to see down here is this little stamp. This represents this image I just published or pushed to the cloud to be computed. And if I sat on this page long enough, you'd actually see a progress bar. Actually, we see a progress bar with this one. You see a progress bar of how that rendering is coming along. And then once it's available, you'll notice those just hopped into render because I just created a new version. But you'll notice you get a little image preview of how far along it is. So I love this render environment. It eliminates the need for render farms or even just tying up your machine resources or setting up renders over your lunch hour or at the end of the day. Actually, a funny story. I was showing this to someone, and they loved it, but in reality, they're like, "Does that mean I have to work now, like while my machine is rendering?" And I said, "Yeah, unfortunately, you do." So we're just trying to increase, value-added activity, and so I love this one here. So let's jump over into the animation workspace. And we're just going to briefly touch on this. Most people think animation is hard to create. I beg to differ. I'm going to show you how this works. I have my timeline at the bottom. I'm gonna explode this fastener and this arm cap, and then I'm going to have them hide after each explosion. Let me show you how this works. I'm going to move my time bar up to about 3 seconds, and I'm going to highlight my fastener, and I'm going to right-click and just say Transform Component. And I'm just going to pull this thing out of the hole to about 100 millimeters and say OK. And when I say OK, it puts a movement action in my timeline. So I can kind of minimize this if I want that movement to happen quicker, right? If it's moving from just 2 seconds to 3 seconds, it has to come from that hole out to where it is now in a second. Or I can come back to 1 second and allow that thing to move a little slower. I'll move this forward to about 4 seconds, and I'm going to right-click on this and say, hey, I want that to hide at 4 seconds. Okay? I'm going to move this up to about 6 seconds. I'm going to highlight my arm cap and do the exact same thing. I'm going to translate this out, say OK. It gives me this movement icon, and then I'm going to bring this out to about 7 seconds. And I'm going to right-click and say, hey, I want this thing to hide. And what I'm left with in my animation, if I hit play, is I get my little camera movement, my explosion, it hides, and the other explosion happens, and then it hides. So this is how easy it is to create an animation, and the best part about this, I'm going to rename this and call this disassembly procedure. I can make as many of these as I want. I could have disassembly, I could have assembly, I could have maintenance procedures, I could have movement or motion, how does my product work? You can build out as many of these as you want. Anyone who accesses this data within the browser can actually watch the animations. So think about that. When I was on my iPad and I was looking at that model, if I would have just opened up the tree of content within that file, I would have actually seen the animations and would be able to play and watch how this thing interacts, how it assembles, things like that. So think technical documentation. So let's move down into simulation. I'm going to bring this back onto the screen. And very first thing I'm going to start with is just choosing a study type. All right, so here we have 4 today: static stress, modal frequency or vibration, thermal and thermal stress. This is expanding over the course of the next month and a half. We're going to be introducing a new FEA solver, NASTRAN solver, developed by NASA, and it's going to bring along with it many more different FEA study types. So think nonlinear, think buckling. We're going to have a lot more capability in this FEA space here over the next month and a half. And that update I was telling you about for tomorrow, I've been super excited about. We're going to have FEA cloud computing. So just like I submitted my render to the cloud, tomorrow we're introducing FEA cloud, which means I get to set up my study on my local machine, but actually have it calculate in the cloud. So I can continue to set up multiple studies for different situations and just continue to submit them to the cloud. And I don't have to worry about my machine being tied up for like hours on end. Because for those of you who have run FEA, whenever you start to get into stuff that's a little more difficult, and you get into like larger assemblies, FEA analysis can take a while to run. And so we're really trying to work on that workflow by incorporating this cloud FEA. So I'm super excited about that, to see that tomorrow morning when I turn on Fusion. So I'm going to hit static stress. Very first thing I'm going to do here, I'm going to come in and I only want to look at the structural components of this subassembly. So I'm going to grab just 3 of these components, and I'm just going to suppress all except for the selected items on the screen. And then I'm just going to apply a material to these 3 components. And for time purposes, because I know we're getting to the end of the hour, I'm just going to say they're all aluminum. And I'm going to come in and I'm going to constrain this subassembly. It's bolted to the Ember printer via these holes. So I'm just going to highlight these holes representing that this back plate is bolted. And then I'm going to come into my loads, and I'm going to specify, just for generic purposes, that there's a 100-pound load pulling down on these faces in here. So we'll just represent, I'm going to come in here to my vectors, and I'm just going to say a negative 100 pounds. You'll notice I'm using this coordinate system up here in the upper right hand corner, and then I'll just say OK. And then very lastly, I want to take a look at degrees of freedom. This is where a lot of people get confused with FEA, but it's really quite easy. We have to specify contacts between components that are touching. Right, so right now, you'll notice my back plate is fully fixed, and that's because we put those constraints on these holes representing that it's bolted. But we haven't specified how this component interacts with this base or how the arm interacts with the arm cap. So we need to specify that, and we do that with contacts. So we're basically saying, hey, are these things bonded? Are they bolted together? Is there adhesive between these? Are they welded? Can they separate when that 100-pound load is applied? Can they slide against one another? We have to specify the contacts between these components. I'm going to run automatic contacts, and what that represents is that there's a bonded relationship between each of these components. So if I come down and, actually we'll turn this off real quick. I highlight bonded contact number 1. It shows you the faces that are touching, and it's a bonded contact. Same back here, my arm and my base, they're bonded where those two are touching. So we're just representing that they're essentially welded or bolted together or something like that. As soon as I have those things set up, I hit solve. And today, like I mentioned, this is being solved locally on my machine. Luckily, this isn't that computational intensive of an analysis, but you know, tomorrow when I get those bigger assemblies, I'm going to be able to push that to the cloud. So that's great. Very first thing I can take a look at is safety factor. Right now I'm looking at a safety factor of 8.52, which is pretty substantial. I don't really have to worry about this thing breaking. Obviously it's made out of aluminum. I only have a 100-pound load. It should be able to suffice. You know, safety factor basically specifies I don't have an issue. I'd have to apply 8.52 times more of a load to even have some sort of issue within this model. Let's move into the stress. Right, so here's the stress induced from that 100-pound load, and I can start to understand where that stress resides. I can even see, I can even see the min and max values. You'll notice down here on this bolt hole down here is where the max stress value resides. And kind of going back to my original point about FEA, I love that I can come in here and see what's going to break, make sure my part isn't going to fail and that it's safe for my product, but I can also optimize. So if I remove areas of low stress, check this out, I can start to map areas of potential material that I can remove from this back component. I don't have a whole lot of stress right in this middle plate. You know, is it more valuable? Is it more cost effective to just remove that material from this back plate? Can I make it cost less? Can it weigh less? I look at FEA for two different things. Obviously, making sure stuff doesn't break and also optimizing my design. And then very lastly, I take a look at displacement. You know, I notice in the front, this thing kind of looks like it's bending down quite a bit. In reality, the max value for displacement is only 0.005 of an inch. And, you know, in reality, I'm looking at a deformation scale of ×2. If I go to undeformed, it's not really visually moving at all when that 100-pound load is applied. So that's exactly what we can do in FEA. It's a great way to start analyzing models to make sure it can withstand the loads that it needs to. And when we're finished with FEA, it's time to actually make stuff. So I'll move into this CAM environment. Oops. And again, same thing. I don't need to run CAM on everything here. Let's just kind of hide some of these other components. We're just going to take that arm cap and we're gonna machine this. We're not going to go through a full operation, but I want you to get an understanding of how this CAM space works. So the very first thing is setup. I'm going to click setup. I'm going to get a yellow silhouette of my stock material. Very first thing I need to specify, am I milling this thing, am I turning, or am I cutting it with water, laser, or plasma? I'm going to leave it on milling, and then I'm going to specify my work coordinate system. So I'm going to say it's normal to this front face of my model, and I want my work coordinate system to be in the upper left-hand corner of my stock. Now another cool thing is we have fixture. If I want to bring in a reference model, like a vice grip, or some sort of fixture that this thing will be sitting in, I can actually specify the geometry that is represented as a fixture, and when it goes to calculate tool paths, it knows to avoid those things. Under stock, I'm on relative size box. It just tries to take and make a relative size around the geometry that you're going to be machining, but you know these values, that's not really stock sizes I can buy. So I'm going to use a fixed size box. This looks a little more nominal, a little more standard. And then finally, I can just give this post-process a name, add a comment, and if I need to do any sort of work coordinate system offset, if I'm cutting multiple parts or flipping this within the same environment, I can do that. So I'll say OK. And now I have my stock, and I can start to specify my operations. So I have 2D and 3D operations for milling. I'm going to start with a facing operation to remove that top layer of my stock material. And all of these operations work the same way. I come in, I specify my operation. Then I specify my tool. Then I specify the geometry that it's going to be cutting within the model. Then I go and specify the heights of my tool during, retract height, the top of the cut, the bottom of the cut. Then I go into passes. So in the cut, how is this thing going to calculate my tool path? Think of like step over, right? Like what's the value, what's the distance of my step over during the cut? And then linking is when how do I enter and exit a cut? Do I come in, and do I plunge into a pocket? Do I spiral into a pocket? That's where you start to kind of customize, your tool paths to your liking. So we're going to start with a tool, and I'm going to come in and turn off my bull and flat and just look at my face mills. And here's one. I get a little quick preview of what that is right there. You'll notice when I choose my tool, it brings in the default feeds and speeds. These can be changed and then set to defaults to your liking. And then geometry, if I want, it understands the top of my stock. So I'm just going to say OK and let it just kind of run its tool path. And it calculates and now shows me its entrance in yellow, its entrance in green. It's cutting with the blue. It's exiting and then retracting in yellow. And I can do the same. I'm going to come into 3D now, and I'm going to use this technology called adaptive clearing. And I'm going to allow this thing to just go through the inside and out with a ball. And we're just going to let it cut because I want you to see how it calculates. So just grab this 1/8 inch. I'll say OK. And I'm not even going to specify geometry or anything. I'm just going to say OK. Watch this. It's going through and it's calculating the tool path necessary to cut this model. And when I'm finished with these calculations, I can come in and simulate in real time with my stock how this is going to look. So let's change this to change it to ceramic so you can start to understand. But I can now come in and see how this thing is going to be cut. I have information about the tool position as it's moving, and I also have overall statistics, machining time, total distance, and number of operations and tool changes. So it's great how we can visually program our model in this CAM workspace, but the best part is if a model change happens. We're almost done here, folks. I'm going to come to this arm cap. Let's just isolate this for a quick second. And I'm going to use this press pull command to do a direct edit. This thing I just decided needs to be 3 millimeters lower. I say OK. It makes that necessary change. I'm going to move back into this CAM workspace. Keep in mind, this could be an interaction between two different people. When I'm finished with the modeling design change, I quickly comment to the manufacturing guy or the CNC programmer, hey, I had to make a change. You might want to update toolpath. I come in, he sees these are invalid. All he has to do, regenerate. And once these toolpaths have been regenerated, we can now quickly go in and just simulate to ensure that our changes have been made. All right, so I'll let this thing run through. Cuts the top of that model down, those 3 additional millimeters, and boom. I have now a connected model from start to finish, from conceptual all the way down to CAM and actual fabrication. So with that, I'm going to pass the baton back on over to Jake, and I appreciate your time today, guys. Thanks. Hey, Jake, you there?
All right. Yeah. Thanks very much, Dan. Guys, I've got one more piece of background information that I think is very very helpful. Actually, let me scoot through. Sorry, I just went through the entire presentation, but hopefully that gave you a better idea of what Fusion 360 is. There is an event that's happening tomorrow. If you did like what you saw today, I would actually encourage you to hold off. Do not go to the website and buy Fusion 360 today because tomorrow there's a one-day promotion, and you can't do it on the 29th. You can't do it today. It is only tomorrow, but you can actually, usually it's $300 a seat, but you could actually get it for $50 a seat tomorrow through the e-store. And if you are interested in that, please let me know. I'm happy to follow up with whoever was on. I can send a link. I think an important piece to point out is, and people have found very, very good value in this, with the purchase of 5 subscriptions, which is $250. it's actually less than a normal subscription would be, which is $300. You get access to our street team. So with that street team comes probably one of the hardest parts about making any type of change, and that's specific training, right? So you get, with Street Team, you get a 4-hour quick start training, which is virtual, and then you'll actually get up to 4 2-hour one-on-one online mentoring sections or sessions that you can go and do a deep dive into any of those workspaces that Dan talked about today, whether it's modeling that's specific, whether you would like to be working more in the CAM space to start off. Part of the great part of this tool is you can bite off what you want to chew and get trained on that specific area. And then finally, you'll have direct access to that street team. So you'll have access to a person, a product expert, when you get stuck. Pretty good value for 5 licenses and a street team trainer for $250. So wanted to make you aware of that. And with that, I'm going to go ahead and leave it open to questions for you, the people that are on the call, and I'll let those kind of come in here as we finish up the presentation.
Yeah, feel free to just type your questions into the the GoToWebinar comments pane, or excuse me, questions pane.
Okay, Dan, we've got one from Joe. He said, do the different workspaces cost extra?
Great question. I know a lot of people would probably assume that if you want CAM, it's going to cost extra, but no. Everything we looked at today is included. There is no different version of Fusion. There's only one version, and everything is included.
Okay, great. I wanted to add one more thing. So what you saw today was Fusion 360. Autodesk is investing in this platform. We're calling it the Product Innovation Platform, where we not only offer an all-in-one CAD, CAM, and computer-aided engineering tool, but also we're trying to improve and make the entire development process easier, from design to make to even use. So they're offering a tool called Fusion Lifecycle for product lifecycle management, and Fusion Connect for Internet of Things. Actually just announced Cloud PDM last week at a big conference of ours called Accelerate. And most recently they've actually they're offering Fusion Configure, adding to this list for configuring products. So I think you can kind of see where Autodesk is going, right? They're moving to the cloud. Product development has been slow to get to the cloud. CRM tools like Salesforce, ERP tools like NetSuite have been making that move. But products development software is much more complicated. So this is kind of a look into what Autodesk is investing in the future, in addressing the future of how things are made and monitored. But today we looked at Fusion 360. So really excited for anybody that has questions. We want to answer those for you as well. All right, let's see if we've got any more. Okay, how much does it cost for viewers to see my files? The answer to that is it is free. So if you have viewers that you're sharing files with that are vendors, or let's say a project manager that doesn't need to necessarily go into the Fusion application, they are able to use the viewer for free. Is there a list somewhere of machines that Fusion works with for CAM?
That's a great question. Yes, we have a post library. It's on Autodesk.com. If you just search for post library, it's going to bring you to all posts that we've put together in a nice, neat library. We cover about 95% of machines. If you do not, for some reason, see your machine in that list, we always like a good challenge. We have CAM specialists that are working with folks to produce the appropriate posts for their machines all the time. So take a look.
Okay. Last one from Susan. Great presentation, guys. Can I buy it now online? You can. I would recommend not buying it online right now, actually, funny enough. What I would recommend is waiting for tomorrow, and I would take advantage of the 5 subscriptions and getting the training from the street team. Have a contact here. and has somebody that can do one-on-one training with you, whether you do want to focus on the CAM aspect or modeling, or you want some general overview across the whole tool. So thank you very much for your interest. I think that's all we have for questions that I'm seeing. Dan, anything else before we break?
Nope. I appreciate everyone's time today. Thank you so much.
Yeah, thanks everybody for joining.
All right. Take care. Bye-bye.